Let's design, print, and test fit a protector doorknob for children, specifically to keep my daughter out of places that I don't yet want her to go. Let's do this in part design. And one thing I've noticed in part design is when I get into a sketch, let's sketch on the XZ plane, and let's say I make an arc and I want to dimension that with a radius, so I hit Shift R, the hotkey for it, nothing happens, right? And then Shift V, no, I can't do a vertical dimension, Shift A. It just seems like in this version, no matter what I do, I can't get the hotkeys to work for sketching. So if anyone knows anything about that, I've been checking around on the forums and haven't found something that fixes this or is an answer at all. Let me know, and I'll like to syndicate a solution for that if anyone has one. So if I use any hotkeys, they'll be down here on the keyboard monitor, but otherwise I'll be using less hotkeys this video, and this is kind of a bear for me to figure out. So I'll grab a horizontal line, we'll stick it right on the origin there. Another horizontal line here. Make an arc that's connected with these points. Again, can't use a hotkey right now, so I'll just manually click the radius, and I'll go with a radius of 30 based on the dimension of my doorknob. Now as we proceed, we might want to give some thought as to how we're going to print this and what orientation that we want. Let's do a 180 degree revolve, and we'll make that symmetric. We don't have to. But I will specify my reference being here. So there's our 180 degree revolve, and yeah, I am envisioning this face here being the mating face to the other side, the doorknob maybe coming in over here, and then the lock on the doorknob, if there is one, would be over here. So let's work with that. I think the first thing I can do is select these two faces and do a shell command. Let's shell this to 2 millimeters. Of course, I think we call this thickness here in FreeCAD with that lingo. We'll select the box, make thickness inwards. Now I'd like to do a 30 degree hole. This would be the hole that your finger goes through to actually engage with the doorknob. We'll give this a diameter of 30. And then we'll do a cut through all. Done. Let's do something similar. We'll sketch on the YZ plane. Right on the origin, we'll make another circle. We'll give that a diameter 30. We'll close and we'll cut through all, making sure that we are symmetric. So this would be the side that the doorknob would come in through, or vice versa. I think you can orientate it either way when we get to the finished product. And we'll click symmetric to make sure that we've got a hole on both and say OK. Alright, next I think I'm going to want to do a tongue and groove to help these parts mate together properly. So let's select this face and we'll create a sketch. I want to make a circle. Let's go with a diameter of 58. And we'll close and pocket a distance of 1.5. And we're good, right? So we have these overhangs here, and we don't necessarily need them because I'll use this as a stopping face instead of this one as a stopping face. So if I highlight these two, maybe we can add a chamfer. And here we're using equal distance. It's about 45 degrees, so that's an improvement. So 45 degrees is pushing it, but I think we can avoid support material on this side due to that. So that'll be pretty cool. Next thing, I want to make a sketch for my snap fits, which will go here on the YZ plane. And it'll simply be a rectangle. several ways to do this, right? I'm going to choose just one. I have to go with my manual dimension because for some reason I still don't have those hotkeys in my sketch. We'll go with 8 millimeters from the origin horizontally. We'll go with a dimension of 5 millimeters on that line horizontally. And then vertically, we'll say from this point to the origin will be a distance of 27.5. And then maybe here we'll go a distance of 2. We're fully constrained, so we'll close that. I'm going to actually introduce a revolve on this. So we'll take a look at this face. We'll go with groove, simply a revolve cut there. And I want to go with my base y-axis. And we're going to go a distance of 10 degrees. I guess I should say an angle of 10 degrees. We'll make that symmetric to plane. We'll say OK, and then mirror that. And we'll mirror that, of course, on our XY plane. So there's our channel on the other side. And I think we're good on this. So I'm going to save that. And then let's do a save as. And I'm saving this as the B side. And let's get rid of the grooves, the chamfer, the pocket. Right, so we're back to pocket 001. And now let's make the other side, or the B side, of this feature. I'm going to start by making the snap. While the dimensions I had just made are fresh in my mind, I'll make 2 concentric arcs. Make a line here. We'll give this line a distance of 2. Give this arc a radius. I remember giving this outer part here a radius of 30. We'll make it coincident, and we'll choose our origin, and we'll make the line coincident on our origin. And then we'll actually design the snap here. And then here. And the question always is, what dimensions do you give a snap to get it working properly? I've made a lot of snaps, so I'm a little bit comfortable not doing the hard calculations. But if you wanted to do the hard calculations, you simply use strain in a beam. You find the max strain of your material, right, what your yield strain is. And from your yield strain, you take 70% of that value, and that's the maximum you want to have your snap flex. You never want to have a snap stuck in a stressed position. You always want it to be held in a neutral position after it's snapped. So neutral position, you go to snap it, goes to 70% of the yield strain max, and then it snaps back into a completely relaxed position. And that's the ideal snap. So from here, we did 27.5. So I'll grab a vertical dimension here and make sure that it's 27.5 from the origin. And then let's, from the origin, I think we did 8.5, so let's do a little bit of relief of 8.75. So it has about a 1/4 millimeter of play and relaxation, so it's not overly tight after we snap it. Let's add an angle, and we'll define from here to this line at 20 degrees. We'll close. We'll go with revolve. I'll select my Y. And that makes a nice annular snap, probably not well dimensioned to be an annular snap, but we want a normal snap, so we'll go with 10 degrees, and I'll make sure that my symmetric to plane button is checked. And that's how we know we're centered. And say OK to that. And so I don't forget, I'll mirror it right away. Again, we want the XY plane to be the mirroring plane. And there we're mirrored. And that looks good. We want to adjust this face because we have a tongue No, we have a groove on the other side, so let's make a tongue on this side. For that, I'll create a sketch on the highlighted face. We'll import, where's my import? There it is. This edge here. And I can use my origin and endpoints of that edge to make an arc. Make a second arc. Line. And line. Yeah, we're good. We'll go with perpendicular. This arc to this line. This arc to this line. We'll give this a distance of 1. In fact, we gave our groove a distance of 1, so to prevent a possible interference, I'll make this point 0.75 millimeters, or 3/4 of a millimeter. We'll close that. And let's go with a boss here of, let's see, we did 1.5 on one, so I'm going to say 1.25 on this one, just to make sure we don't start to interfere with that chamfer section. We'll again do a mirror. All right, we'll choose a pad, and if you're astute, you can also say, well, what if you did one mirror that does 2 features at a time, and that saves your tree a whole feature? And you certainly can do that with both the snap and the boss that we're doing here. So we're mirroring across not our base XZ, but rather our base XY. There we go. We're going to say OK to that. If the audio of my toddler getting upset is coming through, don't worry, she is being taken care of. All right. Finally, again, we want to give thought to how we're going to orient this for printing, and orienting it this way with the print bed down here doesn't make much sense. Sideways would also be a difficult print. I think our best bet is to orient it like this with the print bed down here. We have a little knife point right there, so we probably want to make some modifications to have some better bed adhesion. You can also use a raft, all right? That's possible. I'm going to go probably with just flattening out a little section on this face, just for good measure. And we'll also probably want to consider the overhangs created by these snaps. Maybe I can make a little change to those to prevent an overhanging situation as well. So maybe I can address both in one sketch. Many ways to do this, right? This is simply one. So we're going to go line, line. In fact, I should be in my polyline, shouldn't I? There we are. I'll make a vertical line. I'll make an arc whose center is here. We can give our arc a radius of 30. We can cut our view. And then I'll give this a horizontal distance of 4 millimeters. I'll give this point to the origin a horizontal distance of, say, 25 millimeters. I'm going to import this line. And we'll say this line is coincident with this point. We'll add a line there, and we'll make sure that it's tangent with the arc. Raise this guy up a little bit. We'll draw a line from there to there. It is horizontal. And then let's give this some space here, so just to make sure that we're defined and spaced right, I'll go 2 millimeters. And that should be enough to clear everything. So we'll close that. And now we're flattening out this face a little bit, and we're creating not an overhanging situation on our snap. So we'll do a revolve where we subtract material. The horizontal, yeah, that's the one. And that's great. So we'll say OK on that. So I've designed it with the snaps on the outside. And again, there's no right and wrong way to design things. It's just evaluating your needs. If you wanted to have a completely smooth face, right, it might be better to go with an annular snap and maybe add a little hole that you can put in a flat head and pry it apart if you have to or something like that. You also can make the snaps internal, right, and have them facing to the outside, and that might save you a little bit. But I wanted mine to be pretty easy to take apart without much thought or effort. So I designed it with the snaps on the outside, so it's pretty clear to see the design and how to get it apart. Now it's time to print it, and we might want to go through meshing the part. So that's kind of fun. You can just save as an STL. I like having tight meshes. Call me silly. We'll take this body, and we can create a tighter than standard STL by going to Mesh Design with our body highlighted, Meshes, Create Mesh from Shape, and then you can add in your own parameters if you wish. And with these tighter meshing parameters, we're going to generate a mesh body that will be able to convert to STL. So I'll click on my body, hit the space bar to hide it, and then with my mesh body, I will go to flat lines, and you can visualize how tight our mesh is. Right? So if you have a mesh that is smaller than, say, the tolerance on your 3D printer, you know that the mesh isn't really going to be a factor in the quality of the print. So I like tighter meshes, and we can simply stand on our mesh body, do a export, and this is our B side. So we'll save that. And we can do the same thing with our A side. So jump into our A, looking good. We'll highlight our body. We're already in the mesh design, so we'll mesh from shape. I'll hide the body with the space bar. Take a quick look, make sure our mesh body looks good. And yep, looking good, looking tight. So we'll export our A side as an STL. There we have it. We should be ready for slicing. Alright, so here I am in the printing environment. Move my keyboard monitor over here so you can see any potential problems. And you can paint directly on the object. In fact, I'm going to go through that. Let's import the parts. So we'll make our X rotate 90. And I can make this one rotate 90, but you'll probably see there's a problem. I have an idea of something that's going to happen. If I hit slice now, yeah, we get a problem, right? Error. There's an object with no extrusions on the first layer. And you think, that's strange. Shouldn't the 3D printing slicer just know what the first layer is and put it right on the print bed? So let's take a look. Here we have a knife edge on this part, kind of like what we had on this part, except we flattened out the face. So this is why we want to have some design intent as to how we're going to orient these parts before printing them. Now, if you recall, we put a chamfer right here, and that chamfer was specifically there to create an overhang, right? So we planned on orienting this part actually 180 degrees from how it is now, 180. And if I slice now, notice we have an extrusion on the first layer for both of them. All right, we can take this down. There's our first layer extrusion. So we're oriented correctly, but as you can tell, we have these blue overhangs. And it's too bad these are labeled as overhangs because I really wanted that chamfer to stop that overhang. But we're going to have a lot of infill inside of this anyways, and we're going to have a little bit of infill in here. So what we can do, right, what is an option, is I can select my painting tool and paint where I want there to be support material or where I believe there's going to be an overhang. I can have a little bit more tight control as to how the overhangs are going to be put in the part. Now, obviously, everywhere I'm going to paint is where they're going to automatically add some stuff, so I don't necessarily want to do the painting. I'll just hit Control Z on all of it. And then we'll make sure that this is rotated 180 degrees again. So we'll simply go to Print Settings, Support Material, and we'll generate support material, and use auto-generated supports here. So go with our plater, slice now, and we're looking at a pretty reasonable 3 hours and 4 minutes for something this envelope. I like that a lot. We have this set for PLA. 0.2 speed is a pretty good size for me. So let's export the G code and get this thing printed. So now putting these pieces together, it looked like it snapped together just right, and it resisted motion back and forth, and it spun freely around the doorknob. So it was exactly what I was looking for the first time. If this was helpful, please subscribe, and I'll see you in the next one.